Okay, so today what we are going to do is continue on with solving a system. Last week we did solving a system by graphing, and today we're going to do solve a system by substitution. Today is the 19th. Okay, so solve a system by substitution. Before we get started with that though, we are going to do just like a warm up, let's remember problem together. So this is going to be a get ready, which is to solve by graphing. And my system here is y equals x minus 2 and y equals negative x plus 4. Okay, so that is a review from what we did last week. So we are going to start with that this morning to just kind of remember what we're doing. So remember, when we are doing homework and such, I would like you to please graph on real graph paper. Because this is our notes, I will be graphing on binder paper so it stays in our notes, just saying. Okay, so y equals x minus 2, negative 2. Then we have up 1 over 1, up 1 over 1, something like this. Up 1 over 1. And then we should be graphing this line here. Looks like this. Okay. And then what we have is x equals negative x plus 4. So we have 1, 2, 3, 4. And then we have a negative x. So down 1 over 1, down 1 over 1, down 1 over 1. Graph it here. And we have this point. So this is 1, 2, 3, and I think 1. So this is 3, comma 1. That's what it appears that this possibly is. So we definitely have to check, right? Because this is not a great graphing situation on binder paper. So my check is going to be y equals x minus 2. So my y is 1. My x is 3 minus 2. This is 1 equals 1. That worked out. And then over here, I have y equals negative x plus 4. My y is 1. My negative x, which should be substituting in 3, plus 4. This works out to be 1 is equal to 1. So my solution to this system is 3, comma 1. That is a review from last week on how to solve a system of equations graphically. But today what we are going to do is we are going to take a look at this and we are going to go ahead and solve using substitution. So when we take a look at these equations, I have y equals x minus 2, and I also have y equals negative x plus 4. This is the same system. Woo, sorry, I'm making you guys sick. This is the same system as up above. Okay, what we're going to do is we are going to solve this using substitution. So in order to substitute, we have to have an equation set equal to a variable by itself, right? We have to have a variable isolated. When you take a look here, my top equation has a variable isolated is x. So I'm going to take what x is equal to, and I'm going to substitute it in to my second equation. I can't believe I just said x 5 times and no one even said anything. It is a Monday. That's y, everybody. That is the letter y. If you were unsure, because no one seemed to notice what I'm doing here. That's a y. So let me start over. Y equals x minus 2. My y is isolated. I'm going to take this second equation and I'm going to take what y is equal to and substitute it in for y. So I end up here with x minus 2, that's what I substituted, is equal to negative x plus 4. See, I put these parentheses here so I know what I substituted. This in my top equation is set equal to y, and in my bottom equation, I substituted it where y was. So now I have equations that I'm going to solve, right? I have to find what x is equal to. So this ends up being x minus 2 is equal to negative x plus 4. I need all my x's on one side. So I'm going to plus x, I'm going to plus x. I have 2x minus 2 equals 4. I'm going to add 2, add 2. I've run out of room. I'm sorry. This ends up being 2x is equal to 6. Divide by 2, divide by 2. X equals 3. Now I need to figure out what my y is equal to. So I'm going to come back and I have y equals x minus 2. So I have y equals 3 minus 2. So my y equals 1. And then I should always like do a check and double check, right? So if I have 3 and 1, I'm going to plug those in, substitute those into my second equation. So y equals negative x plus 4. My y is 1. I don't know why I just put a parenthesis. My y is 1 equals negative 3 plus 4. That works out to be 1 equal to 1. So that works out as well. And my solution is 3, 1, which was the same thing as up above. So there you have it. I did substitution and went ahead and solved from there. So we're going to do another example together just to see the different types of substitution that we might come across. Okay. So this is going to be extra example 1. And here's my system where y equals negative x plus 3 and 3y plus 5x equals negative 1. Okay, so remember, in order to solve a system through substitution, we have to have one of our equations set equal to a variable that's isolated. That happens to be the case for equation 1 because it's set equal to y and y is isolated. So since y is equal to negative x plus 3, I can take the negative x plus 3 and substitute it for y in the second equation. So here I have 3 times negative x plus 3 plus 5x equals negative 1. This is now up to order of operations. So start by distributing the 3. So I have negative 3x plus 9 plus 5x equals negative 1. Now I'm going to go about by combining like terms. So my x's become 2x plus 9 equals negative 1. Going to subtract 9, and I'm going to subtract 9. I have 2x equals negative 10. Divide by 2, divide by 2. X equals negative 5. Okay, so here I get this. Now I need to go about looking at my checks. So one of my checks is really, though, about getting y, because I don't have variable y solved for yet. So I'm going to start with this first equation, which was the y equals negative x plus 3. I have y equals negative, substitute in my negative 5 for x, plus 3. This is y equals 5 plus 3. So my y here should equal 8. Now I'm going to go and I'm going to substitute what I believe my solution to be, which is negative 5 comma 8. And I'm going to put that into my second equation to see that it holds true. So I have 3y plus 5x equals negative 1. I have 3 times 8 plus 5 times negative 5 equals negative 1. I have 24 plus negative 25 equals negative 1. I have negative 1 equals negative 1. That checks out. So here is my solution, negative 5 comma 8. That one was a little bit of an easy one, kind of like the first one, due to the fact that I already had one of my variables isolated. So now we're going to look at one that involves us rewriting. Here's example 2. Okay, example 2. Here I have a system, and this is negative x plus y equals 3. And this here is 3x plus y equals negative 1. Okay, so neither one of these are set to have the one variable isolated. So that's the first step that I need to do. So I'm going to go ahead and I'm going to choose equation 1, which would be my top equation, only because it seems like it's going to be a lot easier to manipulate, right? So I start with negative x plus y equals 3. I'm going to add x and I'm going to add x. That's going to give me y equals x plus 3. Okay, again, that's why I went ahead and just started with that one. Now I'm going to take this, and it is set equal to y. So I'm going to take equation 2, which was the 3x plus y equals negative 1, and I'm going to substitute x plus 3 for y because they're the same as each other. So then I have 3x plus x plus 3 equals negative 1. Okay, my parentheses is that substitution step. Now I'm going to go back and I am going to go ahead and work this out for my x. So here I have my 3x plus 3 equals negative 1. I have 4x plus 3 equals negative 1. Minus 3 minus 3. This is 4x equals negative 4. Divide by 4, divide by 4. X equals negative 1. So there you have it. I now need to find my y. So I'm going to take my negative x plus y equals 3. Negative 1 plus y equals 3. This works out here to be a positive 1 plus y equals 3 minus 1 minus 1. This is y is equal to 2. And now we're going to go ahead and we're going to do our checks. So equation 1 check. So equation 1 check. I have negative x plus y equals 3. This is negative 1 plus 2 equals 3. This is 1 plus 2 equals 3. 3 equals 3. That works out. Equation 2 check. This is going to be 3x plus y equals negative 1. This is 3 times negative 1 plus 2 equals negative 1. This is negative 3 plus 2 equals negative 1. Negative 1 equals negative 1. Yep, those both worked out.
Misha?
Yes.
Would your final answer be an ordered pair then?
Yes. So my final answer is the negative 1 comma 2. That's the solution. Okay, we're going to take a look at a word problem to kind of see where we're at with that. So this is going to be E3. And this one says that a theater earns $3,640 from a concert. So a theater earns the $3,640 from a concert. An orchestra ticket costs 3 times as much as a balcony ticket. Okay, we have ticket type and then number sold. So this is going to be orchestra. There's 148, and this over here is balcony. And this is 76. And we are going to write a system of linear equations that represents the situation. And what is the price of each ticket sold? So we're solving for price of each ticket. Okay, so step 1 here in the 5D process of solving word problems is we should always do what first?
Define.
Define. We need to define our variables first. So step 1, let x equal. I'm going to go ahead and just say orchestra because it was listed first. There's no rhyme or reason. Just it was listed first. So let x equal my orchestra. And then let y equal my balcony. Now, a system of equations has how many equations?
2.
Two equations. Excellent. So when we take a look at this, I need 2 equations based on the information that I have here. So what is going to be my first equation?
trying to find out how much an orchestra ticket costs.
Okay. So when we take a look at this, my first equation is going to be set for how much things are costing. So when we look at this, I know that I have my orchestra plus my balcony, and that's equaling a total of $3,640. Okay, did I sell one orchestra seat? Did I sell one balcony seat? So what's missing here? The coefficient. And where should I be finding these coefficients from?
The table and the chart above with
Okay, the table in the chart above. So it might help if we wrote orchestra price or balcony price, because that's what that's going to be actually equal to, because my X is going to need to be 148 times the price of an orchestra, and my Y has to be 76 times the price of the balcony in order to get this total amount of money. Okay, so that represents one of my two equations. My second equation comes from the words of the word problem. So a theater earns $3,640 from a concert. An orchestra ticket costs 3 times as much as a balcony ticket. An orchestra ticket costs 3 times as much as a balcony. 3 times a balcony. That is equation number 2. Now we're going to take that. It's already set equal to an isolated variable. So we're going to substitute and solve. So I've run out of room. Feel free to continue on the same page. I have 148x plus 76y is equal to 3,640. I have 148 substituting my x, which is equal to 3y, plus 76y equals 3,640. Now, this is the stuff that you guys try to do in your head and you show zero work for, which is not okay. So come over to the side, show me some scratch work, please. Okay, I got 444. I saw a head nod, so I'm going to go with it as correct. 444y plus 76y equals 3,640. Combine like terms. So this works out to be 444 plus 76, 10, 12, 520. 520y is equal to 3,640. Now I need to do some division. So divide by 520, divide by 520. How are we doing so far?
Miss Shaw,
Yes.
we're substituting. What are we solving for right now? Are we solving for the orchestra ticket then? Never mind. But because I'm kind of confused because we substitute, so I'm confused what equation we're solving for. What are we solving for?
We're solving right now for the variable y. And when I look back to my defining of the variables, y is the price of a balcony ticket. Okay, so now I have 3,640 divided by 520. So when I do math like this, I look at the front number 5 and 36. 5 and 36, those are close to a times 7. So 7 times 0 is 0. 7 times 2 is 14. 35, 36. Woo. Y equals 7. So this is telling me that the balcony price is $7. Now I need to go back and I need to figure out what the orchestra price is. So if we look here, X is equal to 3Y. So X equals 3 times 7. X equals 21. So the solution here should be 21, 7. And that is telling me in context to the problem that the orchestra tickets cost $21 each. And the balcony tickets cost $7 each. Because it's a word problem, so I need to end with a sentence explaining what I got. Questions? Okay, no questions. So that is what it looks like to solve a word problem for system of equations. So we're going to do a couple do nows in order to practice to make sure we know what's going on. So here are my do nows. This is going to be solving by substitution. So solve by substitution. Okay, here's one. I shouldn't have to write this, but I just want to specify that you need to include your checks when done with this. And then also, so that basically is it for solving by substitution.